In this section, we're going to talk about hyperbolas. This is our last conic section. So hyperbolas are very similar to ellipses, so a lot of the things that you're going to see in this video you should have seen when you watched the video on ellipses. Okay, so a hyperbola, hopefully you remember, is those two parabolic curves that point away from each other. So here's a more specific definition. A hyperbola is a set of points P in a plane such that the absolute value of the difference between the distances from P to two fixed points, F1 and F2, which are the foci, is a constant K. So each fixed point is a focus of the hyperbola. And since this means since these are the foci, the long and the short segment of each of the two colored paths differ by a length of k. So that's just like specifically how hyperbolas are made. So that blue length and that green length are the same length, they're just pointing from two different directions. Alright, so here's the important information. I'll do like I did on the last one and go ahead and put it all on here, and then we'll go back to it. Okay, now go back. Alright, the hyperbola consists of two smooth branches. The turning point of each branch is called the vertex. So we have two vertices on hyperbolas because we have two different curves. Okay, the segment that connects the two vertices is called our transverse axis. So this line right here is our transverse axis, which lies on the axis of symmetry, so that this axis has both a transverse axis and an axis of symmetry. So you could fold this on top of itself, and these would be mirror images. The center of the hyperbola is the midpoint between the two vertices, and it lies on that transverse axis, or axis of symmetry. You're going to also have foci, which are going to be inside, just like they were on parabolas. They'll be inside. And that focal length from center to focus is C. No, that's supposed to be 2C. The distance between the two foci is 2C. The distance from center to vertex is a distance of A. And you also have what's called the conjugate axis. The conjugate axis kind of acts like the minor axis does in an ellipse. The conjugate axis is the perpendicular axis of the transverse axis. And we're also going to have, we're going to look at asymptotes. We're going to make a box, and the asymptotes are going to lie inside this box to give us an idea of our curvature. But in order to find the value of B, that's this value up here and down here. That's on our conjugate axis. So from center to our conjugate axis is a length of B. Alright, so here's our two equations for hyperbolas. If we have a horizontal hyperbola, we're going to have the equation x squared over a squared minus y squared over b squared equals 1. So you notice this looks just like an ellipse, except with an ellipse, these two are being added together. So that's for a horizontal ellipse. For a vertical ellipse, instead of switching a and b like we did with ellipses, we're actually going to switch x and y. So y squared over a squared minus x squared over b squared equals 1. So in this case, a is always the denominator of your first term. Okay, this is for a vertical one. A still represents distance from center to vertex. B still represents distance from center to kind of like co-vertex. And then C represents your focal length from center to focus, or foci. So those are all still the same thing. One other thing that we do need to note is this asymptote. So for a horizontal, y equals plus or minus b over a times x. So you'll notice that a y is over b here. So b is our top term, our top variable, our numerator. And then for the other one, y equals plus or minus a over bx. So in this one, y is over the a. So the a becomes our numerator. That's a good way that you can help remember what the asymptotes are. Alright, so a hyperbola centered at 0, 0 has vertices at plus or minus 4, 0 and a focus at 5, 0. What's the standard form equation of this hyperbola? Okay, so first thing we're going to do is we're going to make a little sketch for ourselves, because a little sketch will help us determine what's going on. Okay, so I have here center at 0, 0. I have vertices at plus or minus 4, 0. 1, 2, 3, 4, 0. 2, 3, 4, 0. Okay, and I also have foci at 5, 0. There's one here and one here. So is this a horizontal or a vertical? Well, this is going to be horizontal because the vertex, or the vertices, are the curves of our hyperbolas. So if it's horizontal, we're going to be using the formula x squared over a squared minus y squared over b squared equals 1. So now we need to find our values of a and b and c. Alright, oops, I did not mean to do that. Alright, so A is distance from center to vertex. So A is going to be a distance of 4. So we know we have x squared over 4 squared, which is 16, minus y squared over b squared equals 1. So we need to find that value of b. Now I'm going to tell you, do you remember when we talked about an ellipse to find the value of b? Right now we have the value of c. We know that c equals 5. So we could use that c squared equals a squared minus b squared, like what we did with an ellipse. Well, with a hyperbola, since we're doing subtraction instead of addition, we're going to do addition instead of subtraction. So c squared equals a squared plus b squared. So we know c is 5, so that's 25 equals 16 plus b squared, subtract 16, 25 minus 16 is 9. So our b squared is a value of 9. So x squared over 16 minus y squared over 9 equals 1 is our equation of this hyperbola. And sketch the hyperbola. Oh, okay. I should have made it prettier. Alright, so when we sketch the hyperbola, come on. Okay, 1, 2, 3, 4, 5, 2, 3, 4, 5. Okay, so when we sketch the hyperbola, what we have to do is we need to create this box, because that's what our asymptotes will go through. So we know our value of b is 3, so we're going to go 3 up and 3 down, and then we take from our vertices down over across. Okay, and these will be the same as our asymptotes. So we always do y equals plus or minus b value, so 3 over a value, 4, 3/4 x. So from 0, 0, if we go up 3, right 4, or down 3, left 4, we're going to get this asymptote here. Or if we do the opposite way, we'll get this asymptote here. That's why that box is important to draw. Okay, so once you have your vertices and once you have your asymptotes on, you go from your vertex and you get closer and closer to that asymptote without touching it. So make sure you always go from your vertex, not from your focus. A lot of people get that confused. And your asymptote is just like the guide for the curvature of your hyperbola. You should get closer and closer to it. Alright, that finishes that one. Alright, what are the vertices, foci, and asymptotes of the hyperbola with equation 9y squared minus 7x squared equals 63? Sketch the graph. Use a graphing calculator to check. Okay, so we're going to need to put this into our standard form, so we're going to divide everything by 63. So I'm going to rewrite this as y squared over 7 minus x squared over 9 equals 1. Okay, is this going to be vertical or horizontal? Well, I have y squared over my a, so this is going to be vertical. I'm just making a note to myself. We know b squared equals 7, and we know a squared equals 9. So in order to find c squared equals a squared plus b squared. So 9 squared, 9 is a squared. So 9 plus 7 is 16. So c squared equals 16, square root, c equals 4. So our focal length is 4. That's from the center. Alright, so we need to find vertices, foci, and asymptotes. Okay, so our vertices are this, oh wait, I messed up because a is always first. So these ones are backwards. So a squared is 7, b squared is 9. There we go. Alright, so I'm going to go ahead and graph these. If I know that it's vertical, I know my focal distance is 4. 1, 2, 3, 4. And 1, 2, 3, 4. I have foci at 0, 4 and 0, negative 4. Okay, what else do I have? Well, I know B is 3. 2, 3. This is the length of my, what do you call that? Not the transverse axis, the other one. The name is escaping me right now. But the shorter one to make my box. Now A is the square root of 7. So if I take the square root of 7, that's going to be between 2 and 3, closer to 3. So I'm going to plot these points here. So I have that point, vertices are at 0, square root of 7, and 0, negative square root of 7. And I need to plot those, that box in order to, oops, right there. So I know my asymptotes are something like that. And then from the vertices, I'm going to go closer and closer to those asymptotes without actually touching it. So there we go. Oh, we didn't find the asymptotes. Y equals plus or minus. Now I have to do the one that's underneath the y, square root of 7, over 3x. Alright, so there's those ones. Alright, and that's basically all there is to know about hyperbolas. So I hope you learned a lot and you saw the differences between hyperbolas and ellipses, and you're really excited to talk about translations in our next section.